more. The next data structure is going to be the queue data structure. So queue, like a stack, is a special type of list. It's FIFO, so first in, first out. So it's kind of like when you go into like a bank or grocery, or staying in any line in a waiting list, and you're trying to get access to a particular service. So you're going to stay in the line. So whoever first get into the line, into the waiting list, that's the one that's going to first get out of the list. So sometimes we also hear that like first in, first serve, right? So that's the same concepts of being in the line and be able to be a queue basically together, one by one, and then we're going to get to the services that we're looking for as well in the same exact order that we get into the list, right? So we have the same thing as we discussed with the stack. We have the same idea that we can implement the queue using array list, or we can implement the queue using linked list. So the also adding and removing element into the queue has its own basically like vocabulary again, right? So over in the stack we call it push and pop. In the queue we call it queuing and dequeuing, right? So in queuing and dequeuing. So if you want to insert element, you call it in queuing, and when you're trying to remove element, you're calling dequeuing, right? So when we're trying to implement this, again, we have to decide that are we going to use array list or are we going to use linked list? And for doing those analysis, we're going to do exactly what we did in this stack. We need to think about that, what is going to be the beginning of the line for us, right, in the queue. And so when the elements are coming into the queue, they're going to go in the top, in the beginning of the line, one by one. Like it's kind of like you're going to the end of the list, right? So we have to know what is the end of the list, what is the beginning of the list. And so in any kind of list, so when there's nobody in the list, the beginning and the end are going to be the same, right? So here the data one is the first elements go to this list or to this queue. And so it seems like it's going to go to the beginning of that because nobody's in the list. But the data 2 comes, since already data 1 is in the line, so it has to go to the back of the line. And so it's going to stay behind the data 1. And the data 3 comes, has to go to stay in the behind the data 3. So the order data was data 1, data 2, data 3. And since it's a FIFO data structure, first in, first out, first data 1 came, so first also data 1 needs to be out. So we're dequeuing the data 1. And the queue data structure, again, as I said, has these two main behavior that we can add element or in queuing them and remove the element or dequeuing them. It has a lot of applications. So anytime you have have any system that you have to implement the list, waiting list for them, and has a lot of application in networking. Anytime you do buffering in a you're going to basically use some sort of a queue in the back, and then you start handling those requests that you have in the queue one by one. So we're going to do exactly what we did with the stack with the MyQueue, and so we're trying to do analysis how we can use array list or limit array list or linked list to act or to behave like a queue. So we're not going to implement the queue from the scratch. We're going to use either my list or my linked list or my array list in the background of it, and we're just going to use the wrapper class for the queue. So we're not really going to implement the queue from the scratch. So again, using the same concepts of composition. So here I'm trying to demonstrate this queue. So this is my service, and the data or requests or whatever you want to call them, whatever is the application of this queue, they're going to come to this line and they're going to wait one by one. So A come first, then B, and then C. So A is going to be the very first element in my queue. So when I'm trying to start giving service to my requests, so A is going to be be the very first one that's getting the service or be removed from the queue, and then next one is going to be B, and the last one is going to be the C. So this is what we want to, our data to behave, or our data structure to behave when it's the queue data structure. So in order to make that happen, it's going to be like opposite of the stack, right? So in the stack, when I implemented using ArrayList, I had to use add last, remove last. But here I have to pick add first and remove last, or add last, remove first. So I had to just basically select those two combinations, so that act as a FIFO data structure. So if I pick the add first with remove last, then I'm going to have this problem that add first is going to be order of n, and that's going to be expensive. So let's go to the other combination. What if I pick add last and remove first combination? Even in that scenario, remove first is going to be order of n. So either add first is going to be the problematic scenario, order of n scenario for us, or remove first is going to be some problematic scenario. So no matter which combination of adding and removing we pick, whenever we're trying to implement the queue behavior, like FIFO behavior with ArrayList, we're going to end up with some sort of an order of n complexity. Let's look at the linked list. So if we try to do linked list, so again we have to pick the opposite scenario. If I pick add first and remove last in the linked list also going to give me the order of n complexity. So that's not a good choice as well. So let me see, like we're basically going to completely get rid of the ArrayList. We'll probably not have any benefit for us to using ArrayList to implement the queue. So also when we're doing the linked list, picking add first and remove last, it's a very bad combination, because that's also going to give us the order of n. But if I pick add last and remove first of the linked list, they both going to give me the order of 1 complexity. So that's a very good combination, right? So even we didn't get that at all in the ArrayList, and in the linked list, the other combinations of the adding and removing, it's not going to give us this complexity efficiency basically. So the best combination is going to be add last for in queuing. That's going to make adding or entering element into our queue in order of 1, and remove first. That's going to be for dequeuing. So basically, just doing at least those two, there's no question that we're not going to even use or implement queue using the ArrayList. So we can just remove that completely from the equation. So we're only going to implement the queue using the linked lists, and that's because it's going to give us definitely a better complexity. We're also going to implement the search. Search, is always going to be order of n anyways, and so that's not going to be a very problematic for us as far as the, it's not going to change the complexity at all. To keep do our bookkeeping basically, no matter which one of this combination I pick, either add last or remove first, I'm gonna have ended up with some sort of an order of n. And if I pick the add first, remove last, also I'm gonna get some sort of the order of n complexity. That's not also useful. So I'm just gonna add in front of it, so we can have that as a color coding it well. So which page 2 combination we decided to use that act as FIFO, and both of them are going to give us the order of n. So again, that's why we didn't decided to not use my array list, and we're only going to use the combination of add last and remove first for enqueuing and dequeuing of the linked list. So let's go to our code. So we're going to create our MyQueue class, and we know for sure that this class only going to use linked list in the background. So MyQueue, it's going to have my linked list in the background. And so same thing, it's going to be a composition, same thing in the stack, right? It's going to be a composition relation. We're not going to implement anything. We're just going to forward. So this is a wrapper class, again, acting as a wrapper or kind of like an interface for us. So it's not really, our client doesn't really know how we implemented the queue. They just know they want to be able to dequeue and enqueue elements inside the queue, and they wanted to act as FIFO to keep the orders, and that's what it's exactly going to do. But in order to store the data, it's going to use in the background, is going to use the linked list. And now we know exactly why we wanted to use linked list, because of the order of the complexity of it is going to be a lot easier for us. If we use array list, we always ended up with some sort of order of n complexity plus the overhead of, adding resizing, right? But if you use the linked list, then we don't even have that. So in queuing, add last, and dequeuing, remove first. So I'm going to also write on the top of that what we did in the stack, that this is a FIFO data structure. So first in, is either FIFO or LILO, which doesn't make any sense. We never use that. So last in, last out, or first in, first out, right? So either of those two, but usually, you hear FIFO or first in, first serve, right? So sometimes you hear that even some restaurants going to tell you when you're trying to reserve your table. And then we're also going to just have this is empty method and print method, just, to make sure that if the queue is empty, we can tell the clients, and also we be able to test by printing out the elements. So just going to go ahead and print or test this as well. Same idea. We're not really implementing anything. We just forwarded, and we use the composition relation between queue and my linked list as well. So let's test that. So you guys had to implement MyQueue and MyStack, and we just want you guys to implement MyQueue and MyStack both using the linked list only. You don't need to implement the stack using array list at all. So both MyQueue and MyStack just implemented with the linked list data structure and submitted into the learning. I'm going to make the link available. I'm going to ask you guys to review this slide or these videos basically before you writing code. Please try to not just copy paste from this video to submit. Try to implement it again yourself. Just give yourself a little bit of a time to think about it and implement it yourself, so you see if you can do it or not. And again, if you have any question about this data structure, please submit your questions using discussion board. Do not email me directly. Your questions, definitely other students' questions as well. Also try to help each other by answering each other. So that is still like participation part of the class. This is still going to be very important. It's going to be also even more important now because we don't have attendance anymore. And so the class participation is going to be the only way for me to understand that you guys paying attention to all the lectures and doing your job. And so being active in the discussion board, it's one way to assure that you were attending basically the class. Okay, so we tested our queue. As you can see, our queue is working perfectly fine. ABC has the order we add element, and as we removed, ABC is also the same exact order that the LA that removed. So we know that our queue is working fine, and so we're good. So thank you guys. And so the next video that I'm going to post is going to be also kind of, maybe you notice that you have two of these videos regarding a stack and queue, and that's because I used the one did the collaborative test, the tool of the e-learning, and my voice completely had issues and noises, and so you can hear really my voice. So I'm using another tool now, and so that's why you kind of see that I am, if I notice, I'm basically talking on my previous video. So from now on I'm going to use this tool, and so hopefully the voice is much better. But again, if you have any problem with these videos, please let me know, so I can fix it at least for the next video, or I can at least redo it, so that way you can have access to better, more quality videos. Next class we're going to try to talk about generics, so next video is going to be about that. So we're going to completely change all of these lists into a generic type list. So it's going to be like discussion about what is a generic type and how we can convert all of these classes that we already implemented into a generic type, so we can have a generic list. And also I'm going to add an interface on the top of all of them, interface list, so all of our classes are going to implement from that interface. So please also review the slides from chapter 24 and 20. So like basically, I guess I put both of those slides into one slide, so review that, and it's going to give you a very good idea about how these list structure implemented and organized in the Java itself. So again, we didn't exactly do what Java did in order to implement the list data structure. we kind of did our own way to do it, but that is also helpful as far as how we're doing to understand and analyze that. So the next video I'm trying to work on it is going to be generic type of this data structure.